Our today's topic is hexadecimal to binary conversion. We have already discussed how the hexadecimal number can be converted into decimal number in lecture 10 and how the decimal number can be converted into binary number in lecture 2 and 3. Following this process, hexadecimal to binary conversion is possible, but it is a lengthy process. Today, we will discuss directly how we can convert any hexadecimal number into binary number. And in the next lecture, we will discuss how directly we can convert any binary number into hexadecimal number. This table shows the binary representation of hexadecimal digits. It is always a group of 4 bits. For hexadecimal to binary and binary to hexadecimal conversion, this 4-bit group is most important. Hexadecimal to binary conversion is possible by 2 methods, as already discussed. Let us consider the example 1, where the hexadecimal number 1C is to be converted into binary number. Here we will follow 2 methods separately. Method 1, it has 2 parts. Part 1, hexadecimal number is to be converted into decimal number first, and then the part 2, decimal number is to be converted into binary number. For hexadecimal number to decimal number conversion, we will follow the standard procedure as we have already discussed in our lecture 10. The step 1, we have to write the hexadecimal number. The step 2, we have to write the weight values in powers of 16. Step 3, we have to write the place values. Then we have to multiply the place values by the decimal equivalent of the corresponding hexadecimal digit. Here 12 is the decimal equivalent of hexadecimal digit C. That's why we have to multiply this place value by 12. And here 1 in decimal system is also equal to 1 in hexadecimal system, and we have to multiply this place value 16 by this 1. And then in step 4, we have to add up the product values, and by following this procedure we get 28. This 28 is the decimal equivalent of the hexadecimal number 1C. Now the part 2, where we have to convert the decimal number 28 into its binary form. Here we will follow the repeated division by 2 method, which we have also discussed in our lecture 2. And if we do this repeated division by 2, then we will get this 0 as the LSB. Then following the procedure, we will get 1 as the MSB, and we have to move up. So the binary equivalent of this decimal number 28 will be 11100. So we can write this 1C in hexadecimal is equivalent to 28 in decimal system, which is equivalent to 11100 in binary. So 11100 is the binary equivalent of the hexadecimal number 1C. The method 2. It is a direct hexadecimal to binary conversion method. Here we have to write the hexadecimal number, that is 1C, and we have to write the binary equivalent of this hexadecimal digit C. For C it is 1100, and for 1 that 4-bit group, that is 0001. So we can write 11100 is the binary equivalent of hexadecimal number 1C. Next, let us consider example 2. Here we have to find the binary equivalent of the hexadecimal number 9FCA. First, we have to write the hexadecimal number. Then we have to write the binary equivalent of hexadecimal numbers as a group of 4 bits. For 9, it is 1001. For F, it is 1111. For C, it is 1100. And for A, it is 1010. Hence, we can say this is the binary equivalent of this given hexadecimal number. Our next example 3. Here also we have to convert this hexadecimal number into binary, and in this case we also follow the same procedure, and following this procedure we can write this is the binary equivalent of 8. The binary equivalent of B is 1011. Binary equivalent of 1 is this, and binary equivalent of D is 1101, and for 4 this is 0100. So this one is the binary equivalent of the given hexadecimal number 8P1D4. Next, let us consider example 4, which is a mixed hexadecimal number. Here also we have to replace the hexadecimal digit by 4-bit group, maintaining the hexadecimal point. And if we do that, for 3 we can write 0011, for 4 we can write 0100, and for C we have 1100, for F we have 1111, then the binary point, and for 6 we have 0110, and for A we have 1010. So this is the binary equivalent of the hexadecimal numbers 34CA.6A. This is in brief about the hexadecimal to binary conversions. For details about the rest conversions in hexadecimal system, we have to continue to number system lecture 12. Thank you.